Hi friends, welcome to this channel. Let's look at today's daily challenge problem. So today's problem is a problem that can be solved by binary search. So here we are given two arrays. One is spells, the other is potions. So a spell and a potion pair is considered successful if the product of their strings is at least success, where success is an given integer. So we want to return an integer array called pairs of length n. N is the number of spells. So where pairs I is the number of potions that will form a successful pair with the ith spell, right? So here we're not going to go over the two examples due to the simplicity of the logic. Let me analyze the constraints. First, both m and n are bounded in between 1 and 10 to the power 5. In other words, those lists can have length as long as 10 to the power 5. Therefore, we still need to consider the term complexity. This is one thing. Another thing is that both the spells and potions are bounded below by 1. In other words, they are all positive, right? And the success is also bounded below by 1. In other words, it's also positive integer. So with that said, we are ready to do the coding. So the logic is that given a spell, right? Given a spell, we want to find potions such that so the spell and so their product, right? The product of their strings, spell times potion, is greater than or equal to success, right? So currently, because all the numbers involved are positive, so we can see we want to find potions such that their power is greater than or equal to success over spell, right? So then actually what we can do, so the potions are not supposed to be sorted. So we can first sort the potions. So we can sort the potions, right? And then find the insertion point of this number, right? This number, let's call it, let's define it by s, right? And then we just count, right? So all the potions to the right of the insertion point are valid ones. Each corresponds contribute to a one pair, right? So this is what we want to do. So in Python, for this kind of insertion, insert, so we can use this module called bisect. So the bisect actually provides a number of functions. One is the bisect left, right? So the other is bisect right. You can use either, but you need to pay attention to their slight difference. So bisect left means that you find the insertion point to the left. All the element is strictly less than the point inserted. Bisect right means that to the right of the insertion point, all the element is strictly greater than the point, right? So now let's look at the coding now. We can get m and n, length spells and length potions, right? So this is very natural. So we want to do sort, right? Potions sort. So here we are calling this method. In other words, we are going to do sort in place, right? So you can print out this potions after sort, right? You can see here, this one is very special because it's already in sorted order. But in example 2, you will get 588, right? This is the one, right? So now let's construct the return. So what we want to return is an array of length say m, right? Let's do this, and then we can write a small function to get the number of pairs we can get. So we can define get count. So you're given a spell power, right? So then we want to get how many portions can form valid pair with this guy given spell. So what we need actually is the success over the spell, right? So this division is legitimate because spell is greater than 0, right? So then we use this element and do insertion. So let's get the IDX. So bisect. So here I'm going to use bisect left, right? So this is the iterable or the list we're going to insert. So we check insert point for this one. So this means we get an IDX. It means that if an ID is less than IDX, in other words, to the left, right, all the element is strictly less than this one. So in other words, in this portions list, there are IDX elements strictly less than this need. So then you use a length that is n minus those smaller one. You will get one that is greater than or equal to. In other words, so we just need to return n minus IDX. So this way, for each spell, we can get the pairs. Now we just need to do a for loop. For I spell in enumerate spells. So we can set result I to be get count spell. And then we just need to return this result variable. So you can run it for the 2 test cases, and then for the generic case, it passes all the cases. So with that said, let me make 2 comments. So the first comment, you need to think how to do the problem if there are many repetitions in spells, right? So actually we don't need to do this. We just need to find the pairs for unique values and then do the assignment. So maybe you can try to write a solution corresponding to this situation. The second comment is that so we have a binary search playlist in our channel. It contains a lot of use patterns, use cases for binary search, and those examples are all based on LeetCode problems. You're welcome to do some practice using that list. With that said, that's it for the current video. Thank you for watching.